So here's where we are. I need to build the nut, and I haven't quite decided what I'm going to build it out of yet. I imagine since it's going to be a long nut that it doesn't really have to be 4140, probably 1018 would work. I might have a chunk of 12L 14, well no I do, laying around. But I don't have I know I don't have a 5/8 inch piece, and I hate to turn a 7/8 inch piece down. So I need to build the nut, and of course after I build the nut I'll decide how long the screw really should be, because I've got way more length than I need. And then I will build the pins for the build. I will take a couple of 1/4 inch dowel pins for the knurl axles, and I will grind a flat on each one and drill a set screw hole. My cyber friend that's kind of mentoring me a little bit on this build said he used 440 set screws, so that was what I'll use. And stick the knurls in it, nut on it, and maybe clean up this tool holder a little bit, and just for cosmetic reasons, and see if I can figure out how to knurl. I'm building the nut for the Scissor Knurl adjustment screw, and this is out of this 1.125 inch diameter piece of 12L14, and it's got it tapered down to match this diameter, which is 0.638 inches. This is the thrust washer that fits down into the one arm of the Scissor Knurl, against which the nut will turn. So I decided to put an 82-degree taper on the nut, just because I think it'll look good. It'll match the 82-degree taper here, which is not important because it's not going to bear on this. It's going to bear on this side, but 82 degrees sounds good. So that's what I'm going to use, and I'm turning on the reverse side of the lathe. Got the carriage locked, and I'll cut this with the using the cross feed and the compound. So I'm only going to show a couple of cuts because the way I've got the camera positioned is really kind of in my way, and I'm turning in reverse. This is a good application for the guesstimator. So I'll see what it guesses. I don't really have enough experience to even guesstimate too well on this taper. But I'm guessing 0.7110 on the way to 0.638. So that's what we'll go with for now, and just take some light cuts and match it up to the part. Well, my digital guesstimator worked pretty good. I think the nut to be is slightly a larger diameter on this surface than the thrust washer, but it's very difficult to tell with the naked eye, and it's just a cosmetic thing anyway. So I'm going to stick it back in the lathe, probably face, I'm not going to face it, because that'll change the diameter. What I'll do to get rid of those marks right there is put it on probably some 600 grit. But I will stick it back in the lathe and drill the hole for the 3/8 24 tap that I'm going to run down it. Okay, I'm going to center drill this workpiece that will become the nut. I'm trying to master the technique of center drilling along this, letting the center drill walk into the spindle axis by not tightening the drill chuck more than hand tight, and getting the center drill shank to our tip to start, and then backing it out, tightening everything up, and then drilling it. However, I don't think I've mastered that. From what I've read, it's supposed to be hand tight, no more than hand tight, with the center drill chucked long and then pushed into the workpiece by hand. So I'm going to give that a shot, see if we can start a little hole in this 12L14. I'm not having a lot of luck there. So I believe what I'm going to do is tighten that baby up. Do it the conventional way. So leave a comment. I'm going to stick a tap drill down there, and I think it's a, let me see, let me look her up. I'm going to tap it for 3/8 24, so I need a cube. I'll be back. All right, I'm ready to run a cue down this workpiece. I'm going to run it down. I need a hole that's 1 inch and 3/4 inch long, so I'm going to run this cue down at about 1 inch and 7/8. I will show you the first part of this effort anyway. Again, this is 12L14, turning at 66 SFM for this drilling operation. Let's see if you can see this. The arbor came loose from the drill chuck. Oops. Where's the right thing on the camera? There we go. Watch. So, I'll be back. I have to fix that. Well, I got the drill bit out, examined it, looked fine. It's an import TIN drill, TIN code high-speed steel, that I've always had good luck with, and I don't know exactly what happened either, other than the drill chuck got was the Chinese job. I'll be upgrading that later. Turning it at 66 SFM, that ought to be about right, or maybe good enough for this 12L14. Seems to be kind of fine now. Both sides. Whoops, not sure. Didn't like the noise. Noises are scary. Perhaps I shouldn't be so intimidated. Still cutting on both sides. So I think everything's fine. Back. I'm about to get depth with this cue-size drill without further problems. However, I'm moving the heck out of it and backing out and clearing the chips. So, this is a comment. Don't know what I did wrong. So being too aggressive, not aggressive enough, not enough lube, too much lube, use too much lube, long SFM, I'm turning to 66 with this tin coated high-speed steel import drill bit. Cheap drill chuck. What's this? Maybe there isn't one. Heck yeah. All right, all's well that ends